Assalamu alaikum wa rahmatullahi wa barakatuhu. Friends, welcome back to my channel. How we can select proper oscilloscope for our project. If we want to buy oscilloscope for our lab, for our field work, for any project, what are the parameters we want to select? This one, this one, this one, this one, or we need PC based, we need USB based. What is our requirement? We will see basic necessary parameters to select an oscilloscope. Oscilloscope is basically a benchtop instrument which displays signal in vertical format, in the voltage and in time period, voltage. We can see the signal behavior, signal level. It changes with change in time. Here, if we see in this level, there is a distortion. Here, there is a vibration. Either it is a sweep signal, but we can say we can monitor the signal. We can see the signal physically, how the signal is behaving in the circuit. It is useful for troubleshooting, testing the signal quality, signal behavior, its amplitude variation, its distortion, and specific area of a signal which contains noise. So we can monitor voltage, frequency, time period, noise, distorted signal, timing signal. If we are working in such a circuit that this signal is starting from here, the second signal must start from the same time. Either it is timing difference, so that is called timing sequence signal, or any other abnormality in the signal, in the circuit, we can monitor that one. Let's discuss the basic parameters. If we want to purchase oscilloscope for our lab, for our work, the first requirement, we must understand what is our requirement, which type of circuit we are testing. We are going to purchase for our field work. That time we must need handheld, portable oscilloscope. If we are working in remote site area, that time which type of handheld? This type or USB based, computer based, laptop based? We need portable oscilloscope. What is the power availability? If there is no line voltage, 220 volt, 115 volt, that time we need battery powered oscilloscope. Each parameter will directly involve in the price of the oscilloscope. If we are going to test some equipment in our shop only, that time we can purchase analog oscilloscope, digital oscilloscope. We need benchtop oscilloscope. What is our budget? You can purchase an oscilloscope from $100 up to $1,000 depending on our requirement, depending on the features, depending on its quality. If you want to purchase a used one, that is approximately 5 to 10 times cheaper than a brand new. What is the future plan? If we are working on any circuit that is 20 kilohertz, 1 megahertz, in future maybe we are switching to any project that is 100 megahertz. If I purchase this oscilloscope, will it work for my new project? Because you have to spend money, so we must consider these three things. What is our use? What is our budget? And what is our future plan? If you are considering that my work environment will remain same, then we can switch to any specific oscilloscope. Otherwise, we need to acquire some higher model. There are different types of oscilloscopes: analog, digital oscilloscopes, digital storage oscilloscopes, digital phosphor oscilloscopes, DPO, and mixed signal oscilloscopes, then mixed domain oscilloscopes, digital sampler oscilloscopes, computer based oscilloscopes that are plug-in type or USB type, then handheld oscilloscopes, then there are digitizers, waveform recorders. Now we will see the basic parameters which are directly involved to select a proper oscilloscope for our project. The first, which type of signal we will measure. Analog signal, sine wave signal, digital signal, digital pulse signals, or mixed signals. And what is expected voltage rating, and what is approximate frequency. Type of signal, voltage, frequency. Voltage can be compromised by attenuating the signal using attenuation, probes, but the most important, that is time base. Time base is capability of any oscilloscope to sample the signal in horizontal axis in this direction. It is involved to measure the frequency and time period. If I will test a circuit that is 20 megahertz maximum frequency, the top level frequency, I will purchase an oscilloscope at least 3 times more than this frequency, so 60 megahertz. If I will test digital signal, the best rule, 20 multiplied by 5, 100 megahertz. Select 3 times higher for analog, 5 times higher for digital. Then rise time. When we are testing higher frequency signals in digital electronics, the rise time is very important. What is rise time? When any digital circuit switches from low to high, how much time it will take to reach from 10% to 90%. That is this time. 90%, 10%. This is time duration. Same way, oscilloscope has its rise time. We cannot find rise time here, but in the manufacturer data sheet will be explained what is the rise time of its circuit. When we will apply signal, how much time it will take to convert the signal. So if we are testing, for example, 3 nanosecond signal, if I am testing a circuit which has 3 nanosecond rise time, so our oscilloscope must be 3 times less. So it must be 1 nanosecond oscilloscope. Any oscilloscope that has 1 nanosecond rise time, it will test this signal easily. Otherwise, it will not give correct reading. 4 nanosecond signal divided by 3 at that time, 1.3 nanosecond oscilloscope will be good. Then the next, sample rate. What is sample rate? When we apply signal to oscilloscope, it is continuous signal, but oscilloscope, digital oscilloscope, will not make a real-time sampling. When we are discussing analog oscilloscope will drive its vertical amplifier and time-based circuit to move its beam to display on the screen. But here in digital oscilloscopes there is a sampling circuit. It will take different points of this circuit like this. Let's suppose one sample from here, second sample from here, third sample from here, fourth sample from here, fifth sample from here. What will the display on the screen? At that time, one sample will here, second sample here, third sample here, fourth sample here, fifth sample here. So our display will in this shape. Our actual signal is this, but due to low amount of sampling, this oscilloscope will not display full signal, the actual signal, the real-time view. To take a real-time view, we need high sampling rate. That is to produce accurate display, accurate behavior of the circuit. Let's suppose if this signal have a rise here, pulse here, or any dip here, if our oscilloscope is not capable to sample in these portions, at that time that oscilloscope will not detect these spikes. To produce a good view, we need higher sample rate. If you have an oscilloscope that has higher sampling rate, that time it will display dots like this. Sampling rate and memory depth. Here are two things. Because it is digital oscilloscope, it is microprocessor based. It will take sample and it will store data in memory location. Then it will display on the screen. How large memory is utilized to store this wave shape data. If we are sampling at higher rate, that time we need a large memory size to store these pulses. Frequency rate, if we are discussing 20 megahertz, multiply by 10, 200 mega samples per second. For that purpose we need large memory. If we have an oscilloscope that can take samples 200 mega samples or above, that will good oscilloscope. So memory depth and sample rate. But when we select an oscilloscope with higher memory depth, that will increase the cost. Then waveform capture rate. If we are selecting analog oscilloscope that is displaying a signal with vertical amplifier and time-based circuit, but if we are selecting DSO, digital oscilloscope, its processor type is serial processor. It will take sample, then it will store into memory, then process, then it will display. So DSO is slow. It can take 10 to 5000 waveforms per second. It is digital storage oscilloscope, and if you are selecting any parallel processing system, that is most of the time in DPO, digital phosphor oscilloscopes, that has parallel sampling, that can take millions waveforms per second. It is 10 to 5000 and that take millions waveforms in 1 second. So DPO is faster. When DPO is faster, its price is high. Then update rate and refresh rate. How quickly it will take sample and it will refresh the screen. How quickly it will acquire a signal and how quickly it will refresh it. What is our circuit type? What is our troubleshooting method? Do we need single channel? Are we using single channel? We need 2 channels? Or we need 4 channels? If we are working on any circuit that is 1 input, 1 output, that time we can monitor input and we can monitor output. 2 signals at a time. For example, I have 2 signals. One is input, second is output. We can monitor 2 signals. If we are working on 3-phase signal and we want to measure 3 phases at the same time, that time we need 4 channel. It will depend on the requirement. Single input, 2 input, 4 input, 8 input, 16 input. How many channels we need? That is called channel depth. When we are increasing channels, it will increase the price and it will decrease the sampling quality. When we will increase the number of channels, it will make capable us to test various type of waveforms, various type of signals at the same time. It will allow us to scan different type of buses, but that will slow down its sampling speed and it will increase the price. If we are selecting 8 channels, 8 lines will be used, and processing system and memory, so everything will increase the price. What is the display quality? What is the resolution? Does it has enough intensity, sharp signal with better resolution, so that we can check the signal types, we can check the signal subtle and different waveforms. Then the triggering, this portion. Trigger has very important role to measure any type of signal. Normally oscilloscopes are with the normal options that are edge triggering, pulse triggering. From here, trigger menu, edge, video, pulse trigger, falling edge, rising edge. Does it has external trigger, any type of bus trigger that can scan different bus systems like I2C, SPI, CAN, line, logic triggering, pulse triggering. So that is a very useful feature that we must know which type of triggering we need. Trigger basically is a feature of oscilloscope that we inform oscilloscope that when this timing signal will arrive, that time it will start to take samples. Then probes. Which type of probe we need? Normally passive probes that are normally used to test AC signals, analog signals. If you are working with digital signals or high frequency signals, the type of probe. Thus, this oscilloscope has capability to accept that probes, differential probes, high voltage probes, current probes. If we are selecting an oscilloscope with a difficult operation, that will become headache. It must be user friendly. For example, here in this oscilloscope I have 2 channels. Every channel has its own control. But if I will discuss this oscilloscope, it has 2 channels, but there is one control for both channels. First I need to enter in the channel, then I will use this knob. Same knob will work with channel 1, same with channel 2. I am changing this and I want to change this channel, that time it will make conflict. So control must be simple and user friendly. This oscilloscope is cheap, but for its setting I need to select the function properly. Then I need to test the frequency, I need to adjust the frequency. If I want to change voltage, then I can select voltage attenuation from here. Oscilloscope must have multiple advanced options, troubleshooting options, measurement options, but its operation must be simple. Discussing this one, I need to set intensity, focus, voltage, time base. But if I will check this one, I will just press one auto set button, it will set automatically. So my wave shape is directly visible on the screen. Third-party softwares. Is this oscilloscope is capable to accept different softwares, different type of buses like GPIB, HPIB, serial port, Ethernet, USB networking, or any bus system. So we can connect with any software that can monitor, that can sample that signal. Then what is connectivity? Is this oscilloscope is connected to internet? We can copy this image, we can save, we can edit, select to external USB. Networking, can we connect printer here? We can take printout. Is it accessible to Windows desktop, for our laptop, for computer? Will it support to run any third-party application that can monitor, that can log the data? What is future plan? Can we extend its memory? Is there any software upgradation? Future support. Its accessories, probes, battery pack, cables, spare parts. So these all features will directly involve in selecting oscilloscope. We must select an oscilloscope with higher frequency bandwidth, fast sampling time, rise time, fast sample rate, fast update rate, greater memory depth, and sufficient number of channels for our requirement, and multiple probing compatibility. And what is the future planning? These parameters will help us to select proper oscilloscope for our project, for our work. I hope this video is informative for you. If it is informative, hit the like button. If you have any question, please write in the comments. Thanks for watching. Assalamu alaikum wa rahmatullahi wa barakatuh.